Hello and welcome back. Today I'm going to be going over the reading section of the SAT, in which I'm going to be walking you through my thought process on how I answer each question, and I'm going to be explaining step by step how I get to each answer. Now, before we start this video, make sure to read this passage in front of you here, so you actually understand what's going on in the passage. So pause the video, read the passage, and when you're done, unpause the video and we'll get started with answering the questions. Now that you're done reading the passage, let's get into answering the questions. So question number 1. Which choice best reflects the author's point of view regarding MRIs? This is the first one. It's the most important tool used by scientists. Well, it is a useful tool, but we never say it's the most important, so we're crossing that out. Next. It's a valuable and effective tool, but should be used sparingly to avoid damage to the body. Now, this is a twist that SAT test makers put in here. It is valuable and effective, yes, but does it cause damage to the body? If we come down over here, it says here that it doesn't cause damage to the body, so let's cross this out. Next, it's a breakthrough technology. Similar to option A over here, it is a good technology, but it's not breakthrough, it's not revolutionary. So we're going to be crossing this out. And last one, option D, it's a useful tool in disease diagnosis, and its specialized training is required to accurately interpret it. Well, by process of elimination, this is the last answer. On to question 2. We need to provide the best answer for the previous question. So let's look at our choices. Lines 41 to 46. Most diseases manifest themselves. Let's go through here. Let's look at line 45 over here. A careful analysis of the images by a radiologist will often yield the correct answer. Well, if we come back over here, we said that specialized training is required to accurately interpret MRI images. And here, we're saying that we need a careful analysis by a radiologist. So, both of those match. Well, we're doing good so far. On to question 3. It can be reasonably inferred from the passage that like a bar magnet, the nucleus of a hydrogen atom does what? Well, where do we talk about the bar magnets and hydrogen atoms? It's over here. The hydrogen proton is like the planet Earth, spinning on an axis. And it's like a small bar magnet. When we place it in a strong magnetic field, the axes line up. Well, when we put it in the magnetic field, is it not responsive to external magnetism? That is the correct answer. It's responding to the external magnetic field and changing according to that. Next, option 4. No, not option 4, question 4. Over the course of the passage, what does the main focus shift from? Let's start down here. An introduction about the properties of radio frequencies to a criticism of the health risks of X-ray devices. It is true, we do talk about this, but we don't start about the properties of radio frequency waves. So we're going to cancel that out. Next, an explanation of tissue relaxation rates. We talk about that near the middle to the end over here, so we're going to be canceling that out as well. Next, the origin of MRIs. Well, we don't talk about the origin of MRIs, and we don't talk about alternative imaging methods. Well, we do talk about them, but in very, very small amounts. We're going to cancel that out. And by process of elimination, this is our final answer. Next up to question 5. What does the planet Earth image in line 5 serve to do? Well, you can see over here we're talking about the planet Earth and how they have a north-south pole, and it behaves like a small bar magnet. Well, if you don't know any science and you know about the planet Earth and its poles, it's an image that can come into your head and help you understand this easier. So it helps to communicate a complex scientific idea using a more familiar concept. Let's go on to question number 6. We're making some really good progress over here. Next, it can be reasonably inferred from the passage that electromagnetic waves in the radio frequency range do what? Well, if you remember earlier in the video, I talked about down here that the waves don't do any damage to the body. You can see it does not damage tissue as it passes through. So it does not create any long-lasting effects on the human body. So that should be the correct answer. Let's go on to question 7 now, and we need to pick the best evidence for the answer above. Well, it's right here, lines 47 to 50. This is where our answer is contained. It does not damage tissue as it passes through. 47 to 50, 47 to 50. Our answer is right there. On to question 8 now. As used in line 42, what does sensitive mean? So MRI is a sensitive test for the detection of disease. Let's just highlight this over here and look at our answer choices. Well, we know it doesn't mean appreciative. We're not thanking the test for the detection of diseases, and it's not unstable, or else that would not be a good result in the end. So we're going to cross that out, and we have two similar options. Both discerning and observant mean to look, like carefully. But which one should we use? Well, if we used observant, we're basically repeating the word detection twice. So we shouldn't be using observant. However, discerning means we're making a good judgment for the detection of disease, which makes the most sense here. We want to detect the disease accurately. So we're going to pick discerning as our answer. On to question 9. The data in the table. So if we look down here, we have a table over here that we can use. So the data in the table supports the author's point that what? Pulse relaxation times can be used to identify different tissues in the body. MRI imaging is safer than other imagings. Infection and tumors look similar, and hydrogen protons behave like a small bar magnet. Well, these have no correlation, so we're canceling that. And nowhere here does it talk about infection or tumors. And we don't see any other imaging techniques here, so how can we compare them? But let's look over here. Pulse relaxation times can be used to identify different tissues. Well, if we look over here, besides the gray matter and muscle for T1, we'll even look here, T2, they're both different. All of these have different T1 and T2 times, so we can accurately identify them. So, wait, we're not crossing it out. This is the correct answer. On to question 10, guys. We're only 2 questions away. According to the table, which tissue is the first to return to its original magnetic resting state? Well, we have T1 and T2. Which one should we look at? Well, let's come up here and see what they represent. The first is the time taken for the magnetic vector to return to its resting state, and the second is the time needed for the axial spin to return. So we're not looking at the axial spin, we're looking at the magnetic vector resting state. So we should look at T1. And now we just look for the smallest value. Look over here, 250 is the smallest, and it corresponds to fat. So fat is our answer. And finally, question number 11. It can be reasonably inferred from the table that some tissues display axial spin relaxation times that are much longer than magnetic vector relaxation times. It generally takes longer for the vectors to return to resting states than axial spins. It often takes twice as long and often 3 times as long. Well, let's look at our data over here. If we look at option D, it takes 3 times as long for the magnetic vector than T2. Well, that's not right. This is 2 times. So that doesn't make any sense. Next, it often takes twice as long. Well, that doesn't make any sense here. 990 are 10 times away, not twice as long. So that's obviously not an option. So let's cross both of these out. And now we have 2 options over here. Some tissues display axial spin relaxation times that are longer than their magnetic vectors. Well, none of the T2 times here are longer than the T1 times. So we're crossing that out. And by process of elimination, option B is the correct answer. And if we look, it's true. All of the T1 times are longer than the T2 times. So that's correct and we're submitting. And if you look at that, we got every single thing right. If you have any questions or need advice, please let me know in the comment section down below. Otherwise, goodbye.